Welcome back. Today we will continue our discussion on industrial safety module 5. Today's topic is electrical hazards. So this is one of the very important topic while considering the industrial safety because due to electrical hazards a lot of accidents has been occurred in industries. So we have to make sure that these hazards are avoided. Okay, so before knowing about the list of different hazards, we should know what is an electrical hazard, because there are a lot of hazards are there, chemical hazards. Okay, different types of hazards are there, we have studied. Okay, so what do you mean by an electrical hazard? An electrical hazard is a dangerous condition where a worker can or does make electrical contact with energized equipment or a conductor. Okay, so by contacting a worker, by contacting an equipment, by electrically contacting an equipment or a conductor, a worker can be can suffer from a shock. Okay, so electrocuted. Okay, so an electrical hazard is a dangerous condition where a worker can or does make electrical contact with energized equipment or a conductor. So this is the definition of an electrical hazard. So the condition depends, it varies. Okay, different types of conditions may occur. So from that contact, the person may sustain an injury from shock, and there is potential for the worker to receive an arc flash or electrical explosion, burn. It may burn our body, thermal burn or blast injury. Okay, that is a severe case. So by contacting an energized equipment or a conductor, a worker can suffer from a shock, okay, or an arc flash, okay, electrical explosion. It may cause a burn to his or body, thermal burn or blast injury. Okay, so there are some electrical hazards are listed. Most common electrical hazards, they are overhead power lines, damaged tools and equipment, inadequate wiring and overloaded circuits, exposed electrical parts, improper grounding, damaged insulation, wet conditions. Okay, we will discuss each one by one. So hazard number 1, overhead power lines. So what do you mean by overhead power line? This is a very common one of the common condition that we are facing, okay, in day-to-day life, because overhead power lines and energies electrical lines have a high voltages which can cause major burns and electrocution to workers. Okay, this is a common case. Okay, it may cause electrocution to workers. Okay, remember to maintain a minimum distance of 10 feet, because for a 50 voltage, okay, minimum voltage 50 voltage power line is above our head, so we have to maintain a minimum distance of 10 feet from that overhead power line. So a minimum distance of 10 feet from overhead power lines and nearby equipment. Conduct site surveys to ensure that nothing is stored under the overhead power line. Okay, nothing should be stored under the overhead power line, because these power lines may fall. Okay, sometimes. Okay, then may cause, so the current is still passing through, so it may cause hazard. Okay, if some type of conductors or something, it cause fire or something is just stored under the overhead power lines, it may cause a serious disaster. So also safety barriers and signs must be installed. Okay, there must be sticker, there must be warning symbols, labels nearby that. Okay, so overhead power lines are going, okay, above the head. Also safety barriers and signs must be installed to warn nearby non-electrical workers of the hazards present in the area. Okay, so number 1, overhead power lines, common one. Okay, a minimum distance of 10 meters should be maintained. Okay, when an overhead power line is going on, okay, from the nearby equipment or from the overhead power line, minimum 10 feet. So it may vary depending on the voltage. We'll see it later. Then hazard number 2, damage to tools and equipment. If you're using damaged tools and equipment, it may also cause electrical hazard. Exposure to damaged electrical tools and equipment can be very dangerous. Do not fix anything unless you are qualified to do so. Okay, if a layman cannot do electrical work, electrical repairing, he should be learned. He should be a professional person to do that. Okay, to do not fix anything unless you are qualified. You should be a qualified person. Thoroughly check for cracks, cuts, or abrasions on cables, wires, and cords. Okay, due to wear and tear, the wires or cords or cables may be cracked. Somehow, some cuts or abrasions. Okay, it may cause some problems. Okay, in case of any defects, have them repaired immediately or replaced. Okay, in lockout, tag out, LOTO procedures should be performed. This is an international procedure for removing or replacing the this cracked wires, okay, cables or cords. These procedures will be performed at all time before commencing electrical maintenance and repairs. Lockout, tag out, lot of procedures are there to protect all our workers on a work site. These procedures are there to work to protect us. Okay, this should be maintained. Okay, then the third one has said inadequate wiring and overloaded circuits. So overloaded circuits are always overloaded. Sometimes it may cause problems. Okay, using wires with inappropriate size for the current can cause overheating and fires to occur. Okay, current wires with inappropriate size can cause overheating. So use a correct wire suitable for the operation and the electrical load to work on. So you have to use correct wire for different application. Different dimensions of wires can be used. Okay, so use the correct wire. Use the correct extension cord designed for heavy duty use. So correct extension cord is also very important. Also, do not overload an outlet and use proper circuit breaker. Proper circuit breakers are important. Okay, perform regular fire risk assessments to identify the areas at risk of bad wiring and circuit. So assess the area regularly. Okay, and we should identify the areas or this risk areas where bad wiring and circuit may cause risk. Okay, so inadequate wiring and overloaded circuits may cause problems. Use separate wires for separate applications. Okay, correct extension cord also should be used. And then fourth hazard is exposed electrical parts. Okay, that is very important. Okay, examples of exposed electrical parts include temporary lighting, open power distribution units, and detached insulation parts on electrical cords. That is very common. Detached insulation parts on electrical cords. These hazards can cause potential shocks and burns. Okay, detached insulation parts, lighting is temporary. Open power distribution unit. Distribution unit is open. We should enclose it. Okay, secure those items with the proper guarding mechanisms and always check for any exposed parts to be repaired immediately. We should not keep our main switch open. We should guard it with guarding mechanisms. Okay, exposed electrical part, that is very important. And then fifth one, improper grounding. If we construct a building, this earthing is very important. Grounding is very important. Proper grounding, proper earthing can eliminate unwanted voltage. Okay, unwanted voltage can again easily go to the earth. Can unwanted voltage and reduce the risk of electrocution. Never remove the metallic ground pin as it is responsible for returning unwanted voltage to the ground. Okay, that is very important. Improper grounding may cause electric hazard. Then damage and insulation, that is very common in our day-to-day life. Defective or inadequate installations is a hazard. Be aware of damaged insulation and report immediately. Turn off all power sources before replacing damaged installations and never attempt to cover them with electrical tape. So never attempt to do that. We always do that. Never attempt to do that, and switch off all power sources before repairing the damaged insulations. Okay, so this is hazard number 6. And hazard number 7, wet conditions. Always keep our hands dry before doing anything. Before you are using an iron box, before you are switching on any electrical appliances. Okay, our hands should be dry. Never operate electrical equipment in wet locations. Water greatly increases the risk of electrocution, especially if the equipment has damaged insulation. Okay, if the equipment has damaged insulation, our wet hands will cause electrocution. Have a qualified electrician inspect electrical equipment that has gotten wet before energizing it. Okay, so these are the 7 hazards, common hazards. We have discussed it. Then if anything happens, what we should do, these are safety measures. Okay, these in an industry, these safety measures should be start from the top to the bottom. Okay, so safety measures: practice safe work environment procedures such as inspection and installation codes prior to their use, staying away from all uninsulated conductors, not to overload a circuit, not having on metallic jewelry and other objects around electrical equipment. Okay, so jewelry conductors, gold, aluminum, silver, all these are conductors. So do not wear expensive jewelries, metallic jewelry nearby the electrical equipment. You have to properly check the wires, cords, and stay away from uninsulated conductors. Okay, and then to overload circuit. Okay, the first one. Second point, in the workplace such as industries, it is vital to train all persons concerning electricity, especially those employees who deal directly with electrical equipment. Okay, it is necessary to train all employees who deal directly with electrical equipment. Okay, you should train them, the management. They should be familiar with the standards of the National Fire Protection Association. Okay, so what all we have to do, what all we have to wear, okay, during our work. Okay, they should be trained properly, and this training and all these things should be based on National Fire Protection Association standards, guidelines given by. Okay, then third point, incorporation of overcurrent protection devices such as circuit breakers, fuses, and ground fault circuit interrupters within an electrical circuit that will ensure maximum safety. Okay, so use this is mandatory. Use circuit breakers, overcurrent protection devices such as circuit breakers, fuses, which is very essential, which we all know, and ground fault circuit interrupters within the electrical circuit. That will ensure maximum safety. Okay, these fuses are important, circuit breakers are important, circuit interrupters are important, fault circuit interrupters are important. Okay, there are a lot of circuit breakers are there. We'll discuss this later. Proper insulation of the conductors in a circuit as well as cords, electrical appliances, and equipment reduces the risk of electrical hazards such as electrical shocks and damage to appliances. Power tools should also be properly insulated. Okay, proper insulation again. Conductors as well as cords. Proper insulation of conductors, proper insulation of cords and equipments reduces the risk of electrocution such as electrical shocks and damage to appliances. Okay, it not only helps us, it not only saves us, but also it saves our expensive electrical appliances. Power tools should also be properly insulated. Okay, grounding of the electrical system within the household or a workplace ensure the circuit is complete. Okay, the circuit is complete only if the grounding is properly done and earth to the ground. Hence, the surge or overflow of electricity is compensated and failure of the electrical system is minimized. Okay, grounding should be done. Then only our work is properly done. This wiring of household or work area, proper grounding or earthing should be done. In the event of an electrical fault, seek the assistance of a professional licensed electrician. Okay, if anything happens, seek the help of a licensed electrician. Okay, then this is a table representing the reaction type and the current type. For different current, what are the reaction? Okay, what all danger can happen to our body. Okay, so it is given that 1000 milliampere is equal to 1 ampere, so 15,000 milliampere is equal to 15 ampere circuit. Okay, so below 1 milliampere, okay, so generally not perceptible, we cannot even detect. Okay, 1 milliampere, up to 1 milliampere there is a faint tingle reaction. Up to 5 milliampere, slight shock, not painful but disturbing. Okay, disturbing, not painful. Then 6 to 25 milliampere for women, it may cause painful shock, loss of control of muscles. Okay, loss of muscular control. Then 9 to 30 for men, the same thing. The freezing current or let go range, individual cannot let go but can be thrown away from the circuit if extensive muscles are stimulated. Okay, because we all know that may cause persons to thrown away from the devices. Okay, this may cause thrown away from the devices. 9 to 30 milliampere, 50 to 150 milliampere. Extreme pain Death is possible, respiratory arrest, severe muscular contractions. Then death is possible. Okay, very serious. Then 1000 to 4300 milliampere. That is 1 ampere to 4.3 ampere. Rhythmatic pumping action of the heart ceases. Okay, pumping action of the heart ceases. Muscular contraction and nerve damage. Nerves may damage. Death likely. Then the last one, 10 ampere or 10,000 milliampere, cardiac arrest, heart problem. Okay, severe burns, death is probable death. Okay, this is a different range of current and different reaction for body. In electrical protection methods, as we discussed in our overhead line protection hazards, we have discussed up to 10 feet. Minimum is a 10 feet. Okay, distance we should keep from our equipment, or we should keep from overhead lines. Okay, this is up to 50 voltage. So these two columns, tabular columns, will give us the left hand side the voltages and right hand side minimum clearing distance. So up to 50, there is 10 feet distance should be kept. Up to 50 to 500, 200, 15 feet, 200 to 350, 20, 350 to 500, 25, 500 to 750, 35, 750 to 1000, 45, then over 1000. So this feet minimum clearing distance is established by the power line owner or operator or registered professional engineer who is a qualified engineer with respect to electrical transmission and distribution. Okay, this over 1000, we should consult a professional person. Okay, then protection against overloads. How we can protect ourselves or our appliances from overloads? So overloads can be short term or long term overloads. It may cause short term, long term, the short term overloads or long term overloads. It may continue for such a long time, or it will disappear after some time. The protective device chosen must not trip on momentarily, okay, or short term or current events that are normal for the piece of equipment it is protected. Okay, so momentarily the protective equipment, the circuit breaker, should not trip. Okay, you should maintain. Okay, so short term, we will discuss short term. Okay, so the protective device chosen must not trip on momentary or short term or current events. Electron devices, for example, may create inrush currents as their internal power supply and filter circuits start. Okay, so whenever the circuit starts, whenever the internal power supply starts, it may create inrush currents. So these inrush currents typically last only a fraction of seconds, and it may hardly cause any problem. Okay, so there is not a problem. Inrush current. Then there are different types of delay curves are there, and these delay curve depends on different types of circuit breakers. There are 4 types of circuit breakers we have discussed. We will be discussing thermal breaker, thermal magnetic breaker, then assembly magnetic circuit breaker, then a pure magnetic circuit breaker. For all of this, we have 4 different types of delay curves. So first we will discuss what are the circuit breakers, and then we will discuss the delay curves. Okay, so what is a circuit breaker? Thermal circuit breakers. Thermal breakers incorporates a heat responsive bimetal strip or disc. This type of technology has a slower characteristics curve that discriminate between safe temporary surges and prolonged overloads. It is appropriate for machinery or vehicles where high inrush currents accompany the start of electrical motors, transformers, and solenoids. Okay, so thermal breakers, it uses heat responsive bimetal strip or disc. Thermal means heat, so thermal breakers make use of heat responsive. The heat responsive sensors, heat responsive bimetal strip or disc. So whenever there is a surge in heat, the circuit breaks. This type of technology has a slower characteristics curve. So as we all know, thermal circuit breakers, the second row, first column, thermal circuit breaker. In the y-axis it is given as time, and in the x-axis it is given as current. Okay, so thermal circuit breakers has got a slow characteristics curve. Okay, it takes some time in order to trip, in order to break the circuit when the current increases. Okay, safe. So it has a slower characteristics curve that discriminates between safe temporary surges and prolonged overloads. Okay, so these short term surges are not so important. not very critical, but prolonged overloads are critical. It is appropriate for machinery or vehicles where high inrush current accumulates the start of electric motors. Okay, whenever when switch on the electric motors, high inrush current comes. Okay, but that is inappropriate. High inrush current may come. It is appropriate. It is nothing danger. Whenever we start electrical motors, transformers and so on. There are some thermal circuit breakers with hot wire elements which provide faster switch. Okay. They provide a low-cost solution for appliances and printed circuit board protection among other applications. So it is mostly used in printed circuit board protection. Okay, along with other applications. Then thermal magnetic breaker. Okay, thermal magnetic breaker combine the benefits of thermal as well as magnetic circuit breaker. They have a thermal delay and avoid noise and stripping caused by normal inrush current and magnetic solenoid for fast response to high current. Okay, so for normal inrush current, this thermal this technology will be taken care of, and for high currents this magnetic solenoid will be taken care of. So that is why the combination of these two will work. Okay, both standard thermal and magnetic circuit breakers are sensitive to ambient temperature. Okay, this is sensitive to ambient temperature, but they can be selected to operate properly in a wide temperature range. For wide temperature range, there are different varieties of thermal magnetic breakers are there. So combination of thermal and magnetic. Okay, time versus current graph. It is not so slow. Okay, like thermal circuit breaker as we see. Okay, then third one is a magnetic circuit breaker. It can be combined with the hydraulic relay to make it tolerant of current surges. These hydraulic magnetic breakers are similar to thermal magnetic in that they have two-step response curve. They provide a delay on normal overcurrents but trip quickly on short circuits. Okay. So, but this curve is somewhat similar to the thermal magnetic circuit breaker curve is somewhat similar to thermal magnetic curve. Many hydraulic magnetic circuit breakers are available in a selection of delay curves to fit particular applications. So there are a lot of varieties of hydraulic magnetic circuit breakers are available in market. Hydraulic magnetic circuit breakers are not affected by ambient temperature, but they tend to be sensitive to position, because that is these breakers should be avoid from this gravitational field, gravity. So we should keep it in a vertical plane. Okay, we should keep it in a vertical plane. So these breakers should be mounted in a vertical plane to prevent gravity from influencing the movement of the solenoid. If mounted on a different position, derating may be needed. Okay, so the magnetic circuit breaker, its curve, it's a combination of, it is somewhat similar to thermal magnetic circuit breaker. Okay, time versus current graph. Hydraulic delay is used, and also this magnetic circuit breaker is also known as hydraulic magnetic breakers. Okay, then fourth one, pure magnetic circuit breaker. So the third one is not so pure. Fourth one is pure magnetic circuit breakers operate via a solenoid and trip nearly instantly as soon as the threshold current has been reached. So that is very important. As soon as the threshold current has been reached, it nearly trips. This type of delay curve is appropriate for sensitive equipment such as telecommunication equipment, printed circuit boards, and impulse disconnection and control applications. Okay, so pure magnetic circuit breakers. Okay, we can compare magnetic hydraulic circuit breakers and magnetic circuit breakers. So whenever this current threshold current comes, it momentarily trips. Okay, so magnetic circuit breaker. Okay, so this much all. Thank you.